G'day everybody and welcome back to the channel. Today I want to get these driver boards done, both of them. But before that I want to get these capacitor banks done quickly. Now I've been doing some thinking about some components. Now I've been tossing up whether or not to bypass the 10 ohm resistors with capacitors. My logic was because it's a really low resistance, it's not really necessary. And I've had a look at all the different schematics that I've got on my computer because I have quite a few different amplifiers. Actually, you know what? I'm going to pause the video because I've got another schematic on my phone. I'll just transfer that to my computer too. That'll give us one more to look at. Alright, so I know all these schematics are ripped off. Half of them, oh, maybe a couple, like that one. Possibly that. I'd say those two are ripped off of what's his name? Self. These are rubbish designs off of just crap websites. But these guys rip designs off of other people, you know, and then play around with them and re-upload them, you know. You'll find an input stage from one amplifier and a VAS from another amplifier and an output stage from another amplifier all stitched together. But anyway, and then I've got a couple of schematics here from stuff that I've been working on. I've got this I've been looking at too. This is a project that I want to do coming up. So I've been looking at a few different schematics and I've noticed something that seems to be common across all of them. So starting with this one, we do have bypass capacitors here, but the resistor is 100 ohms. Okay, we do have 100 ohm resistors here with no bypass capacitors, but that's neither here nor there. Looking at the bigger picture, you know, it seems with lower resistances, no. With higher resistances, yes. And that's what I would think. But I just wanted to have a quick look at other people's designs, you know. Now, obviously, a lot of these amps are different topologies too. But I mean, when it comes to getting a signal into the base at the output stage, it's all pretty much the same thing, you know. If your resistance is too high and you need to bypass for high frequencies, then it's going to be the same whether it's a quasi output stage, a Darlington, you know what I mean. It's not going to change. So anyway, from what I'm gathering, you know, it's going to be fine the way it is. So I'm just going to keep 2.2 ohm resistors on the base of the power devices, 10 ohm on the base of the drivers. That's it, nothing else. So that's what I'm going to do. I mean, obviously we're going to run tests and stuff on it, you know. We'll see what we get out of that. But for now, I'm just going off my design and data sheets. I think what I've decided to do seems right looking at other schematics, so yeah. Anyways, we'll see. Like I said, we'll do analyzation when it's up and running. I have not played around with amplifiers for a few years, but I think that is right. I'm going to get all these capacitors in these boards and then I'll come back and solder them up. Alright, let's get these soldered up. But before I do that, something's just caught my attention. In the last maybe video or two videos, I can't remember actually, to tell you the truth, I've been talking about using a suckout capacitor between the bases of the drivers. I was just having a look at these schematics a second ago that I was showing you guys. Sorry, I'm going to have to pause the video. My computer's lost the history just for this one tab. Alright, I've got it. So I was looking at this Hummingbird amplifier project. Now this thing's designed for quality, not quantity, you know. We've got a 22 nanofarad capacitor across here. And across this resistor we have a 100 nano. So that's the bases of the outputs that have got the 100 nano. And the drivers have got a 22 nano. I'm thinking, because I remember, see, here's the thing. The reason this interests me a lot, when I built this amp years ago, I had problems with cross distortion, which is why I ended up with, 200 ohms across here. Anyhow, the resistors fixed that problem, and it's not just those resistors, it's the, I'll have to get the schematic to show you exactly what I'm talking about. It was these two 430 ohm resistors in conjunction with those 200 ohm resistors that solved my problem. Now, I'm thinking about adding a 10k resistor here too. I haven't decided upon that yet. I might go have a look at some other designs and see if that's a common practice or not. Because this amp did have a problem with cross distortion. I did get rid of it, but there's probably still a little bit there because I didn't have great measuring equipment back then, and yeah. Why on earth is one of these smaller than the others? I don't like that. You know what? 3 of these are smaller. Be back in a sec. I know these bigger ones have got a lower ESR because I've tested them. Alright, problem solved. That was actually just an oddball one. These grey ones have got a lower ESR than the red ones and yellow ones that I've got, so I've chosen them. Anyway, I'm going off track. So I'm thinking, because the problem is essentially there, just doled down, I was only looking at the signal on a rudimentary scope. I had a distortion analyzer, but I didn't have a powerful enough load bank, and I still don't. That's something I'm in the process of sorting out right now. A huge non-inductive load bank. So I wouldn't be surprised if there's still a little bit there, is what I'm trying to say. I think what I'm going to do is I'm going to put a 47 nano capacitor across these two. And a 4.7 across the pre-drivers. I'm not going to do it straight away. I'm going to build the amp as it was because I want to test it without that and see. Ideally, the less capacitors I can have in the audio path, the better, in my mind. So I'm going to actually test it and see how it, behaves as is. But I just want to point that out. That's something we're definitely going to be looking at and most likely doing. It just depends how well the cross distortion problem is actually addressed. Now, the other thing I'm thinking about is where I want to put these. Because this was a, afterthought sort of thing. I think I'm just going to snake them on the end of the board. Yeah. I'm just going to drill some holes and sneak these on the end of these boards. Oh no, I've put capacitors in the wrong way. How did I do that? What? Alright, I'll turn these two around and I'll drill some holes. Alright, I've drilled those holes and put my capacitors in the right way. So I'll just mount these now. Alright, let's get these soldered up. And we can get our driver boards done. I cannot wait to get this finished. I'm going to have so much fun. Need to turn my soldering iron up. Maybe just a little bit more. Now we're cooking with mustard gas. These capacitor banks are going to have some really low ESR. I'll get the other one done off camera and then we'll get started on the driver boards. I still have to get cases organised for these amplifiers too. Alright, I'll get the other board finished and then we'll do the drivers. So that's the capacitors, capacitor banks, boards, whatever you want to call it, finished. Oh my god. You've got to be kidding me. I could shoot myself right now. Oh my god. Today is not my day. I've had a couple of bad days making up boards. What on earth? What was I thinking? You know what? I'm just going to leave it because these two middle tracks aren't connected. So I'll just have to run a wire each end of one bank. It is what it is, you know. It's all good. It could be worse, you know. These could be sharing one track in the middle and, you know, that would suck. So thank God I didn't do that. Probably should have, come to think of it, but oh well. That's alright. Alright, I'm going to get on with the driver boards. So I think I'm just going to start at the top and just work down. So the diode, resistor, electrolytic, film cap, and then just work my way down the board. I'll just preform the parts off camera. So something I wanted to mention, with these pots, pretty much all pots, they usually come set halfway, but I don't like to trust that, and what's more, in my drawers, who knows if I've taken one out, stuck it in a breadboard, used it, and then put it back in. So always check half the pot to make sure that it's got half the resistance across it. If it doesn't, you know that it's not set halfway. By the way, I've changed the 47 microfarad resistors to 100 capacitors to 100 because I've got space for it. I had 470 originally and I went down to 47. I've gone back to 100. So that's what I'm using. You know, I've been thinking about this and I'm just going to take these capacitors out and turn them around and do it so they're facing the right way, because I should have left it one solid track in the middle. What I'm going to do is I'm going to go back and put bars across just using this to make it essentially one track so that the resistance between each capacitor is lower, you know. Yeah, so I will fix this up. I just don't like the idea of using a wire to connect it, and yeah. Plus I can't bridge the middle two tracks together with the capacitors around the wrong way. You know what, likewise I'm going to change the 100 nanofarad caps that I had with the 47 mic electrodes that are now 100 mic. I'm going to make them 220. The thing is, I've got to use these because of the voltage. These are the only sort of film cap that I've got. I do have other film caps with higher voltages like 250, 400 volts, but I wanted to use something around 100 volts to keep the size reasonable. These are, 100 volts. They're nice big ones, so have a lower ESR, and I have measured that too. And that's also the reason why I've chosen the 224, because these Mylar caps don't have a very low ESR down in the lower frequency range, so to try and squeeze a little bit more out, I've put bigger caps. Also, I've got 2 lots of transistor pairs off the one set of cap banks, so I wanted to make them a little bit bigger. So that's my reasoning behind that. I'll just put these other 2 off with the rest of the components. I gotta say, this was the best purchase I've ever made. Having a desoldering gun just makes things so easy when you make mistakes and when you got to desolder stuff to repair it. Well, that's that problem solved. So now I'm thinking what I want to do. I really should have just left a track going down the middle. I didn't think about that when I laid it out. I'm just going to lay bars across each solder joint basically. That will do the trick. I guess at the end too. I'll work it out. Alright, that's all the components prepared for one board, because I'm only going to do one on camera. I'm going to make up buzz bars to go across the middle rows for these first, just so that that's done, because I like to finish something before moving on, if possible. I say if possible because I have so many projects on the go in here. But yeah, so I'm going to go get some wire cut up and we will bridge this middle bar out. Alright, so that's sorted. Now I've done a little bit of research in... Man, my screen won't lock. Sorry about that. I've done a little bit of research in the background. I've had a little read on DIY Audio's forum or whatever you want to call it, and I found someone, or a few people that were discussing charge suckout capacitors, and I was looking at what values they were suggesting in these different amps, and then I came across another page, or another forum that someone was talking about it, and then I went and had a look at some schematics to see, because they'd only put the values of the resistors in between the bases and the capacitors and the type of amp. They didn't put the topology, so I wanted to go see the topology. Now, what I've noticed is with Darlingtons and triple Darlingtons, I've found quite a few charge suck out capacitors, and when there's a lower resistance, it's usually closer to 100 or 220 nanofarad. So anyway, here's what I'm going to do. I'm going to put 100 nanofarad across each of these. So one there and one there. And across the bases of the ones before. Sorry, I've gone silly. Yeah, across these two 430 ohm resistors, I'm going to stick 10 nanofarads there. Obviously, once the amp's powered up, we can play square waves through it and stuff like that, and look at it on the scope and do FFT, all that sort of stuff. And we can see how it's behaving and adjust values. But as I said, I was playing around with it when I built it, and cross distortion was the last thing I was playing around with before I was playing around with negative feedback. And then I was still playing around with negative feedback because I was playing around with input stages. I never decided upon an input stage. So that's what I'm going to do. I'm going to put 100 nano and a 10 nano cap in there. And my other reasoning for wanting to add a little bit, give it a bit more help to suck the charge out of those bases, is because looking at the data sheet for the devices I've put in the output stage, the capacitance on their base could be a little bit bigger, and the output capacitance, than the transistors I had before. The other thing is all the transistors I have now have a higher gain than what I had before too. So for those reasons, I don't think it's going to harm it in any way. Now, I don't want to go any bigger than 100 nano and 10 nano because I don't like putting capacitors, in the audio path unless it's bypassing something. So, in between bases, for example, in between emitters of the two sides, between bases and collectors, all that sort of stuff. If I can avoid it, I will. I mean, I'm pretty sure most people do. You try and avoid that and only use that as a fix if you have to. So I'll go select some capacitors and then I'll come back. The other thing I've decided to do is fuses for the DC side of the amp. So I've grabbed 2 lots of 4 fuse holders. These 4 are these old school, I think they're like silver or pewter or something, plated. Look really cool. They change colour as they're getting old, but I know the look of this metal. It's got that dull, silvery looking, I think it's pewter because it's changing colour, but that could just be flux too. Hard to say. Anyway, I've got fuse holders. I'm thinking around about 7 to 8 amp fuse. Something else I did have a look at was what other people have used for fuses in their amplifiers that are around the 250 watt mark, and that's how I've come to the ballpark of 7 to 8 amps. There's a cross between my math and looking at other designs. So I'm thinking a little bit smaller, but I haven't completely made up my mind yet, but it's going to be around that ballpark. But I do want to add fuses. So I'll probably just make up a couple of little boards that just have the fuses on them. Actually, I'll have a think about that now so I can give you a definitive answer of where I'm going to put it. Let me have a think about how I'm going to lay everything out in the case and where I actually want the fuses. And then I can think about where they're going to go, because I might be able to build a board that houses a few different things like the rectifier, fuses, a few different things. Let me just have a think about layout. Actually, you know what? Scratch that idea, because I'm not going to be able to make it on the same board as the rectifier, because the rectifier has to go in the start of the cap bank, and the fuses have to be in between the output of this and my amp. So I am going to have to make another little board. There's no way of avoiding that. I've just Yeah, no, it doesn't matter how much I plan. That's not going to happen. Alright, well, I'll just put these off to the side for now. I've got to select some fuses. I don't know if I'm going to have the right rating. I think I'll just go with 7 amps because I've got a schematic for a PA amplifier that was 250 watts a channel, 4 ohm stable, very similar topology to what I'm building. So they were using 7 amp fuses. I'm going to abuse the crap out of this thing. That is a PA amplifier. It's designed for abuse. It's a PA amp. So I feel pretty comfortable going with that rating without doing the maths on it, If I, let's say, just saw the fuses in some home theater amps or something like that around the same power rating, I wouldn't be so happy trusting that figure. But yeah, I'm pretty happy with that figure because of what it's in. So I'm not going to bother doing the math for that one. Like I said, I already did a bit of math and I came to a slightly smaller figure, and so, that'll do. I'm just trying to think what I want to do next. I think I'll go through this and I'll sort out my fuses, and I'll go have a look at my PCB scraps box and see if I've got a couple of bits of board or maybe a long strip I can cut into 2 little boards to make up something to house 2 fuses for each amp. I'll be back in a minute. Yeah, well, I can't make this up. I was just looking at the just looking at the fuse on this schematic. Like I was saying, this 250 watt channel, each channel PA amp, and it's a 7 amp fast flow. Look what they've done on their rail. They've got 104 times 2 with an electrolytic going to ground. That's just hilarious, because I was going to use a 104 and I was like, you know what, I'd rather go with a 224. Seems they had very similar logic. They just used 2 capacitors. Anyway, I'm just going through boards, but I've just got to size up how long the fuse is because this board's got some scratches on it, so obviously can't use that bit. Alright, there's enough space there. I'm not going to do this today because it's late and I don't want to make noise. Actually, I might be able to just do this with a Stanley knife. Give me a minute, I'll be back. Okay, I cut a couple of little pieces of board. So I'm just going to mark out some tracks and make up some fuse boards. Alright, so when I've got some time, I'll etch those up. All I've got to do is just drill 3 holes in each pad, 2 next to each other for this to sit in. And, well, actually 3 in a row really, because they're long ways. Hole, and then another hole for the wire. So I'll just go etch it and drill 3 holes in each pad. Solder these in. That will be my fuse holders. I'll just go put this off to the side. You know what? I'm just going to do it now whilst I'm doing this. Might as well just kill the time. Not kill the time. I was trying to say do 2 things at one time. I mean, yeah, that kind of does kill time, doesn't it? Yeah, I'll just do this up here. Why not? Then I don't have to wait for boards. Yeah, just put it all in there. I forgot to get a tissue ready then to wipe that down. Man, I keep forgetting to lock the screen. I'm really sorry about that. I've got to get back in the habit of, it's like I've fallen out of the habit of locking the screen. Anyway, I'm going to see if I've got 7 amp fuses now, and if I do, or whether I do or not, we're going to put these boards together. Well, I'll do one of them on camera. I won't bore you with two, but I'm going to put those boards together now. So I'll just see if I've got the fuses I want first, and then put them off to the side and get a start on that. All I've got for now is 10 amp fuses. I'll still use them for now whilst I'm waiting for 7 amp fuses to arrive. I'll order them straight away. I'll still use them. I mean, any fuse is better than no fuse. It just means about 500 plus watts. You know, at least double that. I mean, it'll be fused at 500 watts. But, per channel. Sorry, per rail. Actually, I just realised something. That's only going to do... Hold on, I need to do some more math. Alright, I've just done a little bit of math. I'm actually going to go with 8 amp fuses for this build. So 10's not too far off. And I was getting worried about the size of the fuses not being enough. Actually, that's something else I need to think about. Sorry, 1 minute. Alright, I was having a silly moment. I was thinking that I need double the amount of fuses, and then I realised that each fuse is for one rail, which is doing half the sine wave. Anyway, silly moment. Alright, so that's not too far off what I want. I actually want 8 amp fuses. I'll just go put these off to the side, and then we'll get started on this then. I've just realised I actually need to make up 4 of those boards, because I need, well, 2 more that are just for one fuse, if that makes sense, because I need to run a fuse in series with the active wire coming in from the 240, so I'll go cut a couple more boards. Alright, that's what I'm going with. I just did these ones by hand. I know it's not the prettiest thing in the world. They're for fuse holders. It really doesn't matter to me. I'll put them in after I take these ones out. Alright, let's get on with this. Okay, well, those 2 boards are done, so I'm going to put these 2 in. Cool. All right. Let's give these a quick clean up. Oh no. Shit. Oh no. We're not missing the copper, but there's still copper on this one. I'm just gonna... How bad is it? You know what? Let's see how it retakes Sharpie without cleaning it all off. If it's easy to get Sharpie straight back on it, I'll just put them straight back in. I don't know what happened there, because I cleaned the boards. This is what I don't understand about etching. Sometimes, well, that board doesn't need to go back in at all. Yeah, it's just this one. I'm just going to do that with the Dremel. I can't be bothered trying to do that again. Too much messing around. I'll go clean that up, and I'll be back in a minute. Alright, that's better. Oops, I left the other board somewhere. Bloody hell. How do I do these things? I found it. I always lose things in here. Alright. That etchant did start to go through. I can see where it's just started attacking the copper. It hasn't really made it thin. Yeah, no, I can't even feel those lines with my nail. It hasn't made it thin, but I can see where it's gone through. And one of these has come out worse than the other, so I'm not too sure what happened there. We'll see if the new boards do the same thing. Well, that's one, and that's two. I'll just go and drill the holes in those boards now. You know what I've just remembered? In all of this talking and doing 100 different things, I have almost forgotten about these suckout capacitors that I want to put on the output stage. So whilst those boards are doing, we'll do that. Where to fit it? I think I might just put them across the resistors. I'm going to go do a bit of research on the best capacitor type. I would imagine a mylar or a ceramic. Probably a ceramic is most likely what you would use, but I'm not sure, so I'm going to go check. Also, I'm not happy with the solder there because it's only around half of the resistor leg where it's hooked around that hole in the circuit board and not around the other half. I'm just going to flow a little bit more solder on there. Put a nice big glob on there. Alright. Not exactly how I want it, but alright, now it is. Now what that other one could do with a bit more too. You know, because these wires are only just, you know, stuck through a little hole, if that's what you want to think of it as, in the resistor leg that I formed in, you know, the little hook that I've put through the hole in the circuit board. I've then opened that up a very small amount and slid the wire in through that. So I just want to make sure that, you know, there's plenty of solder there, grabbing onto every surface it possibly can. Yeah, this side's fine. Alright, I'll go work out what type of capacitors and grab a 10 nano and a 100 nano, and I'll be back in a minute. Boy, where do I start? This is going to get confusing. I've just worked out 3 things at once, so sorry if I'm going off topic again. The reason my Sharpie's coming off the board is because it was way too bloody hot. I forgot to turn the hot plate off. Pretty self-explanatory. Actually, I think that's still too hot. I'm just going to wait a bit more. Something else I just realised. So the original amp, I was using a transformer that had 63 volt outputs. .47 volt outputs, rectified ends up being 63. And the transformer I've got now is going to be about 55 volts after rectification, I think. Anyway, I did the math on the resistors that let the current into the bias string, because that needs to be closer to 10 milliamps. I've got 1.6 milliamps now. That's not good. More annoyingly is that changes quite a few things, because if I have to make the 33k resistors smaller in value, I need to work out exactly what my original bias current was. Actually, what am I saying? I know what the original power rails were. I've got to go do one more calculation. So I'll go do that. Sorry, my bad. Alright, interestingly enough, it was only 2 milliamps. I'm actually surprised that that was sufficient current to bias the string on. Now, in terms of the diodes being biased on enough to thermally track, it definitely worked because it did a wonderful job of thermal tracking. I just can't understand how that didn't cause any distortion. don't know if there's something I'm missing here. I'm just going to do a little bit more digging into this circuit and have a think about it. I don't want to get something wrong, you know? Alright, I'm going to change them to 27k to accommodate for the new transformer voltage. Now, that I won't have to change anything else at the moment, but when we get this built, I'm going to be very curious to have another look at THD. I just feel like there's something I'm missing here, like maybe I've got the wrong resistor value and they weren't 33k, because I don't know if you guys watched the first video where I was getting all the plans together and going through my schematics from years ago, but I was missing schematics, and I also didn't have the final schematic. The only schematic I could find was basically like one of the first, maybe I think it was the second schematic I drew of it, and it still had a lot of errors and I changed a lot of component values. So yeah, I've got a little bit of working out to do. So I'll just put 27k in there for now. That's going to put 2 milliamps through the bias string. That is the smallest figure you'd usually see. It's usually about 2 to 10 milliamps if you're using a diode string across a triple Darlington, and you're using the string for the compensation of the buffer, the driver, and the output stage, if that makes sense. So 1, 2, 3, 4, 6 diodes, if they're normal p-n junction diodes. Anyway, I'll go change these resistors. I'll be back in a minute. Okay, that's 4 27k resistors, and I've put 4 in the bag for the other board. Let's see how we're going. Getting there. Sharpie is coming off a little bit. This last lot of ferric chloride I've had has not etched as quick as the first lot. It's quite interesting. Anyway, now that I've addressed that, I think 2 milliamps will be enough, because this amp runs on a higher voltage. You know, it's not like it runs on 28 volts or 35 volts or 33 volts or 40 volts. You know, it used to run on 63. I've sized the transformer to a more appropriate voltage, because yeah, 4 ohms, what, 33 volts is about 250 watts RMS. I think it is, something like that. Which is what I'm designing the amp for. I'm not too worried about 8 ohms so much, but we'll see what it can do at 8 ohm. Actually, let me do some maths, and I can tell you now, because I know how hard I can drive this. I don't see any reason why I won't be able to get 250 watts out of it in 8 ohms as well. It's only got to do about 45 volts. It's going to have a 55 volt rail at least. It's a triple Darlington. You knock off the 4.5 volts, something around that. Yeah, I can't see any reason why I'm going to have trouble getting it. I've just got to supply sufficient drive, take thermals and stuff into consideration. But I mean, driving an 8 ohm load's going to be easy for it. So, yeah. You know what I still have to do? I have to get the capacitors for the bloody suckout capacitors. My head's everywhere. The thing is, I built this years ago. It was never complete, and now I've come back to it years later. I'm trying to reconstruct the circuit almost out of memories and some bits of paper that had errors on them and changes and stuff crossed out, and yeah, and then on top of it, I'm trying to make changes to it and improve it, and you know, I'm just all over the shop with this one. Yeah, my apologies. I will make an updated circuit diagram soon. I've decided whilst I'm putting this together and things are coming back to me and all that sort of jazz, I don't want to just keep scribbling stuff on paper when the values are going to potentially keep changing, you know. So I'll wait until I've got this put together, turned on, running, and then I'll take the values down. Then we'll start doing tests on it and see how good it is, change stuff if need be, and if I have to do that, I'll make another schematic again. Alright, I was trying to work out the quality of the capacitor, ESR, voltage. Anyway, I've come to this. These are 100 volt MKTs, 10 nano, 100 nano. So I'm going to use that. I haven't found any other schematics on my computer or any reference to anyone using any specific types. I've seen ceramics used. I wanted to use something better than that. This Hummingbird amplifier project that's published in Practical Electronics, which looks like it's been ripped off to me, but anyway, it might not have been, might just be similar to something else, but anyway, they surprisingly are using MKTs, so that amp's got some good specs. And I've seen a lot of things that Practical Electronics have made, and depends who makes it, to be honest, who publishes the circuit, but I will say I do agree with a lot of the stuff that I've seen, so I'm comfortable doing that. I'm going to go with that style of capacitor. So, yeah. I'm still contemplating putting a resistor across the bases of the pre-drivers, and here's why. Okay, you've essentially got suck-out capacitors, if you think about it, because you've got the bias capacitors, the 100 nano and the 4.7 mic electrode that go across the bias string. But they're capacitors, they do behave different to resistors. Also, you've got the bias string, but those are diodes, they behave different. I feel like some resistance there may be beneficial, but I'm not sure. I'm quite curious. I think I might actually pause the video and do a little bit of research, see if I can dig anything up. I probably won't. If I can't, I'm going to do a little bit of math about with how much current's flowing in the area and what sort of value I could put in there without running into bias problems and stuff like that, and see if it's even a plausible thing. Because I don't want to put a really high value of resistor in an area that's got a lot of gain and high impedance, because, you know, resistor noise. So let me consider that. You know what? I'm going to put 10k resistors in there. Here's my logic. The diode string, when it's conducting, all the current's going to be going through that. So I don't see how the 10k resistors could, how do I explain this, pull all the current away. You know what? I've misplaced my 10k resistors. Let me find what I've done with them and we'll continue. Alright, so that's 10k resistors. I'll form them up after I've put these capacitors on the output stages, but actually I've forgotten about this. Oops. That's all the component selections. I think we're good this time. Let me just go take this to the sink and wash it. I'll be back in a sec. We should have, whoops, wrong tweezers. That would have gone bad. We should have more boards. All right. They came out fine. The Sharpie did start coming off, but that was, like I said, because I had heat on it, too much heat. That was my fault, not some fault of the solution. So all good. And that's probably what happened to me last time too, when I had a problem with Sharpie coming off. I can't even remember if I mentioned that in a video, but I had a little bit of Sharpie come off one time. But I'm going to put that down to heat too, because every etch that I've done, other than those couple, have come out absolutely amazing. And, you know, I'd say I've found the right stuff to be using now. Alright, we now have fuse boards. DC fuse boards, AC fuse boards. Obviously I've got to drill the holes and put the fuse holders on them. I decided to just make these up, seeing as, I mean, I'm in the build process, I might as well just keep going with everything. So I'll go put these off to the side, but we now have DC fuses and AC input fuses for both the amps. Alright, so I've cut those 10k resistors to size. And now I just want to get these suckout capacitors in here. So the 100 nano ones, whoops, they're going to go here. I've got to work out how I'm going to fit them in here. This is going to be interesting. I wish I had thought about this before. I think I'll get them in here off camera and then I'll come back and show you the result. Alright, well, I've strung those just across those 200 ohm resistors. Done the same for both outputs. So that's that. On here, I guess I'm going to have to do the same thing. I wish I had thought about this before. I really wish I had thought about this before. Oh well. It is what it is. In the grand scheme of things, I mean, you know what? I forgot the resistors to them. Although there isn't really a good spot for them. I think that's probably the best spot anyway, if you think about it. I mean, what was I going to do? Put them on one board or the other, one on each? Still, I would have long traces and have to connect them in the middle. So, yeah, I probably got the shortest path like that. So, I mean, that's all right. But, yeah, I'm spewing about that. Anyway, let's start getting this done. So, I'm just going to start tinning stuff and putting it down where it belongs. That's 224s, 220 nano films. I'll do the 100 microfarad electrolytics next. I can't remember what I've chosen as positive. I think positive is going to be, yeah, that side, the left. Oh yes, I've got my NPNs on the left. Makes sense. Going from 47 to 100 mic and from 100 nano to 220 literally just fits there. Good call, I made that. talk about just fits. Yeah, that's alright, I guess. I mean, it literally just fits, but it is what it is. Alright, I'm going to put the resistors there, two 10 ohm resistors. Alright. I'll do the two diodes as well, the 1N4007 diodes. Not the best fit, I won't lie. I could have done a better job. It'll do. Excuse me, warming up because I've turned some heaters on. It's pretty cold around this area, but I can get my house pretty toasty warm at the same time just by turning a few heaters on, so it's not too bad. What do these 430 ohm resistors? I don't know how I'm going to fit. Oh yeah, in there. The MKT that goes across the 430 ohm resistors. What goes here? Diode. UF407. think I might pause and do most of this off camera because it's really fiddly. And it's just going to take a long time. That's what happened with the last video I uploaded that I was doing building in. Starting to build this thing. When I looked at the video time, it was like 2.5 hours or something. So, I don't know, I'll record it. So I'll record it and I'll just put it in the title. I'll get these UF 4007 diodes in place because they go there and there. It's a little bit tight. Talk about just fitting. This board's going to be pretty tightly packed. Almost put that diode around the wrong way. Oh man, come on. Go and make up a couple of normal boards with drilled holes, putting components through. Now I've lost my technique for doing this. I'll take that, that's good enough. Let's get that MKT in here. I'm just thinking if I want to insulate it. No, it's alright. How are we going to do this is the question. I might just solder it. Yeah. I'm just going to bend the legs on a right angle where the end of the resistor is. Not a right angle and another angle, just a right angle. Like so. Yeah, that's alright. I can do that. And I can just move it out a little bit so it can't short on anything. Kind of like that. Now it's buried. I don't like leaving pins half covered, if that makes sense. You know, when you put a bit of solder over a pin and you can still see some of the pin underneath it. Yeah, that's not going to go anywhere. I know it looks like it is, but it's actually not. Definitely not. I don't know which one of these transistors is the NPN and which is the PNP. MPSA 42 is what? A PNP. 42 is the PNP. What? I would have thought that'd be the NPN. What the hell? Oh no, the 42 is the NPN. Wow. Alright, that makes more sense. I mean, usually the first number is the NPN, you know, but always do due diligence and make sure. Oh yeah, the pin out, that's the other thing. Collector's pin 3, emitter's pin 1. Emitter is pin 1, we need the emitter here, so it's going to go facing that way. Going to put a bit more solder over these pins. That's better. Yeah, that actually wasn't soldered in the first time. Should I do the bottom one too? No, I'll wait till last because it's probably going to end up in the way of stuff. That did not go to plan. I swear, I think my light's going out in here. It's been getting darker. I'm gonna have to do something about that. Because I get a little bit of a shadow and I'm having trouble seeing. It wasn't like that a year ago in here. It's gradually happened. I'm gonna go get a drink and come back. All right. Alright, I'm back. I think what I'm going to do is I'm going to get a bit of this made up and sort of time lapse it, if that makes sense. Like what I did with the capacitor bank, just to save time for you guys. We're getting there. I'm almost out of solder, but I've got more rolls, or at least another one roll, so that is all good. I always get them down in one go, and the first one I do on camera, it just goes terrible. Isn't that always the way? You watch, this one will go perfectly. Let's put one leg in, and then wet the two pads at the same time and put the other two legs in. Yep, like so. Perfect. Anyway. Now that's our offset adjust, not our bias adjust. Turning them all the way up or all the way down is going to have bugger all influence on the bias level. I mean, they're 500 ohm pots in series with 33k resistors. However, they do have an immense effect on offset voltage. So by having 10 turn pots like this in series with the bias current sourcing resistors, I can trim the offset to literally 0, you know, which is good. Why wouldn't you want that? It's just occurred to me, I need to make up some links. I need 2 little links. I need to go from there to there and from there to there. I've been having a bit more of a think about the preamp for this thing too, seeing as, you know, I mean, I'm not far away from it. And I have to say, let me just get this up on the computer and I'll just show you guys what I'm thinking about doing. Alright, let me just turn the lock off so I don't make everyone go blind. Alright, this Hummingbird amplifier, I actually quite like the front end on it. And it's very suitable for mine. I mean, what do we have here? A triple Darlington. You know, if you take out the safe operating protection, the VB multiplier, you know, it's literally my amp, you know. Sticking that front end on here would be so easy, it wouldn't be funny. So I think I might take that because I've had a look at the specs on here and they're bloody nice, you know, and that is a good output stage. I mean, it's not far off what I'm making, and there's a reason I'm making it. I looked at the specs on here and they're good. Like I said, I'll show you. Here we are. So there's the claim to fame. So you guys read that for yourself. So, you know, I mean, that's indicative of a good front end and a good output stage. So I think I'm going to adapt that to this circuit, change whatever values I have to change and stick it in here. This amp's going to be a bloody good amp because it already was a good amp. I just never finished it and never had a front end on it. I'm also interested, see, this is the reason why I have got the preamp and this board completely separate because I want to put different preamps in and play around with them. I might want to change values on here, even the output stage too. I might want to do a bit of playing around. If it comes out good, or without much mucking around, it comes out good, I'll probably leave it how it is because I've got plenty of other amps that I want to build that are way higher quality, you know, like those SAT15 devices, stuff like that. So I might just use this to say bass amps or something like that to power subwoofers. I don't know. Just build a lot of amps and I'll take my pick out of them what I want for what I want, if that makes sense. Alright, so just trying to think what I should do next. Might fill up these middle spots. Actually, I'll do those last. No, I'll do them and those and everything down here. That seems like the most sensible thing to do. Yeah, we'll do that. Let me just think about some thoughts regarding layouts. I just want to have a think about where I want to put the components here. Oh no, you know what I just realised? I've put the 10k resistors here. I saw the orange, and because I forgot I changed the bias source resistors from 33k to 27, I've just gone and picked up these 10Ks because I saw the orange and I've gone, oh yeah, that's the 33Ks, forgetting that, you know, we're not using 33K anymore. Oh, man, I'm going to carefully take all these off. I think that's the better way to do it. I'll be back when I'm done. Making some progress. I've got those jumpers in too. I think what I've decided to do, diode, electro, film, resistor. And I'll just put the diodes in first because they're reverse protection diodes, so they go the opposite way to the way the current's flowing. So I figured I'd put them in together. Saves me putting one in the wrong way later on. And that's what I'm doing with the electrodes too, because they're polarized obviously. Oh shit, I just realised what I'm doing. I just put these two upside down. It's a good thing I you know, have a quick look after I do something and have a think about it. Because I make a lot of silly mistakes. And I would let a lot of magic smoke out if I didn't double check my work, I can tell you that. That's better. We've got our PNP on this side and our NPN on this side. Well, we should. Yes. It would not be good if I did not have it that way around. Yes, film capacitor. Should turn the legs around on that the other way. That's alright. We've got plenty of track. Doesn't have to go on the pads. It's only got skinny little legs anyway. Cool. Might just bring this a bit more over this way. Cool. Why do I have 4 10K resistors here? Hold up. Did I put the 10Ks in this bag? Okay, I didn't put the 10Ks in the bag with the components for the other board. That's why I've got 4 here. I've noticed that's been a common theme since I got all the components out. I've put a lot of components back in here that weren't supposed to be in here, and when I took everything out of the bag in the first place, which was supposed to be for 2 boards, half the components I had enough for 4 boards. Don't know what I was thinking there. Anyhow, might just tin these tracks a little bit more. That did not go to plan. Yeah, I just chipped the end off that resistor. It's only a bit of paint. You know what I'll do? I've got some lacquer here. Instead of changing the resistor because of seriously just a little bit of paint, it's not the resistor that's chipped. None of the resistor's damaged. It's just the paint. I'll just get this onto something. Get a little drop over that to coat it. Just so that no moisture can ever seep in between basically where the cross section of the paint is and the resistor, if that makes sense. Just got way too much in there. You know what? I'll just change it. Screw it. Because you know what's going to happen. When I clean the board, all that stuff's going to come off. That lacquer's not going to stay there. I'll just get another one. It's all good. Because if I forget when I clean the board, I'll take all the lacquer off this resistor without replacing it. Let's pause the video whilst to get another one. Alright, I've got another resistor and I've tinned it up. Much better. Gotta be gentle with these small parts. What happened was I was squeezing fairly hard on the end of the resistor where the cap goes over the former inside it, and that and the heat just, when I slipped, it just peeled the paint off with it. I'll take that. I'll clean the board up afterwards anyway. I still got to clean the output stages up too, so all that lacquer will get removed. I'm going to have to go get some more solder in a sec. I just realised my bloody fan is not on. How much soldering I've done today and I did not have the fan on. Oh, goodness. Waste no solder. Jeez, I might as well just hold it. That works. Alright. That's a bit of a dangerous fit. We could do it, I guess. These capacitors have steel legs, so they're like extremely stiff. If it was copper, I wouldn't do this because I'd be worried if I ever drop the board, just the shock could make the component sort of bend, if that makes sense. But yeah, no, it's way too, you hear that? It's very springy. I'll lift them up a little bit too so the legs aren't just away from the tracks in terms of this way, but also in terms of height. Yeah, now they can never touch the tracks. They're so stiff, like just trust me, the legs are steel, they're not copper, and they're really stiff and springy. It's not going to go anywhere. I need more solder. Well, I guess we won't see any more of this anymore, because the last time I went to Dracar, it's changed. Oh, just thought I'd give you guys a look. What do you guys do with your old solder rolls? Do you keep them? I keep them to wind air core inductors for crossovers, for small speakers. You know, 75 watts to 150 watts in that ballpark. You can't really make any inductors, well, not really for mids and woofers past that wattage on a form of that size. I mean, you can do it, but it's not going to be quality, you know. You'll be sacrificing Q factor and other things, basically, is what I'm trying to say. What have we got left? Just these two diodes. Wow. Now, when I built this amp and had it running, I did not have any compensation capacitors between base and collector, but I put all the pads there. So when we analyze it, whatever we need to add, we can add there. These diodes have got copper legs. It's hilarious because the legs are 3 times the thickness, literally, of that MLCC cap. Goodness, I've gone blank. MKT capacitor. And the MKT capacitor having the steel legs is so much harder to bend than the copper diode legs. Wait a minute. Oh yeah, that's right. Okay, one driver board complete. I'm going to get some PCB cleaner on it and give it a brush, and I'll be back. Okay, well that's the first board finished. I'm going to leave the video here because I'm sure that's gone on quite long enough. And I'll get the other board finished, and then we can start designing preamps, and then we can build the thing. Alright, I'll see you all in the next one. Thanks for watching.